Welcome to the labs associated with ECE 3300 Introduction to Electromagnetics. In the first day of 3300, we were posed with the design challenge shown on this slide. By the time we reached the end of the first design challenge, we ultimately determined that we could use spread spectrum time domain reflectrometry, or SSTDR, to determine whether there are any problems with any of the wiring on an aircraft. The idea of SSTDR is to send, even while the airplane is flying, a very, very low voltage signal down a live wire. Then by studying the reflections that we get on the wire, we can check if the connection at the end of the wire is okay, and we can also check whether there are any faults or issues along the length of the wire. We need to use a very, very low voltage signal so that the wire can still be used to carry the signals it is intended to carry while the aircraft is flying. And an example signal that could be used at low power is a sine wave that is modulated by a pseudo-noise sequence. So far in this course, we've been analytically solving how simple pulses propagate down transmission lines. For example, we tracked the leading edge of a pulse using bounce diagrams, like the one shown here. This was helpful for developing a basic understanding of how voltage and current waves travel along transmission lines, and to ultimately help us to come up with the general idea of using time domain reflectrometry. But it's a big step to go from point A, where we have the simple analytical calculations that we've been doing, to point B, where we have a real-life SSTDR system in an aircraft and operating while the aircraft is flying around. So why me get from point A to point B? Well, on our way to point B, we would probably want to have some sort of proof of concept demonstration. I'll put that here. Proof of concept demonstration. And that we would want that because we want to show that the technology is worth pursuing and it's worth investing funds and time and into implementing it. And in order to develop this proof of concept demonstration, we would need funding also to help pay for any of the supplies and the tools that we might need, and any computer software and so forth. And of course, also hopefully funding to help compensate us for our own time as we work on developing this proof of concept demonstration. But in order to get funding, we need to ask for some funds, and maybe from the company we work for, if there is internal funding available, or perhaps we could ask a government funding agency or another funding agency for funds. That would be external funding. And the way we would ask for funding is to write and submit a proposal to our employer or to the funding agency. So we can imagine here we need a proposal to ask for funding. We'd have to get funding. We'd have to work towards a proof of concept demonstration. And then I'll put a dashed line here because this is where we want to end up, but there's probably a few more steps here that we'd have to consider. Let's first talk about this proposal. A proposal to work towards a proof of concept demonstration, it would need to include details of our idea, and we'd need to certainly motivate why this would be important. So we'd have to have some motivation. We'd have to talk about the potential impact that this could have, our solution could have. And we'd also have to have a convincing plan on how we would progress from the simple analytical analysis we've done so far to the proof of concept demonstration. So I'll say here to work towards that proof of concept demonstration. And if this is successful, we or someone or a company who might be interested in that technology could then work on developing this technology further, and that dashed line that we drew on the previous page from the demo to point B, then they could work on developing it further and getting it to the real-life SSTDR system on an aircraft. So now the question becomes, what steps might we include in our proposal? What would be part of this convincing plan as we work towards the demonstration? Would we run experiments? How would we design those experiments? Would we perform some more calculations? Would they be by hand or by computer? So what do you think? Come up with some ideas of what would you include in a proposal for how you would get to a real-life demo.